Oh, welcome back to the video to fix stuff. This is a late 1920s Standardyne, I think it's a model 29 radio. It's like a cookie tin case. The lid just comes off. Yeah, it's got a crinkle paint finish, which of course some of the crinkle paint is falling off, but it's typical for being 90 years old. I did kind of have this one apart before to have a look at it, but I did not try powering it up, so I just took all the screws out of everything to shield off the power supply. You can see the power cord is not in the best shape, so I'm going to try to tape it together there. This is it's a 7 tube, at least in the RF. Let's see, we've got what? 3, 6, yeah, 7. Well, but this is the audio output tube, so not 7 tubes doing RF amplification. This is probably an AF tube here, so I've got at least 1, 2, 3, maybe 4 RF tubes. This would be the detector tube, the type 27. You can tell by the vastly different grid structure in that one. You can see how these ones have a flat, stretched out grid. Let's see if there wasn't so much dust on it. So these ones have like a flat, stretched out grid, or not grid, a plate structure. Versus these ones, if you look down in there, it just has like a real skinny thing right in the middle. So that's the type 27, and this is the type 26, has the much larger oval plate structure. And I'm not sure how well you can see that, but so I did have a look at this, and I also pulled up the schematic, and I had to order this, which I'll explain in a minute what that's for. Let's take a look at the schematic first. This is a TRF set, by the way, not Standardyne. Here, I pulled up here on the bendy pad. See, it's an AC model 29, and then we can see we've got our power supply up here. See, what do they have? The input here comes in, go up to the switch, and then over to the primary side of the power transformer, and then you've got your filament takeoffs. Looks like 4.5 volts, 5 volts, 1.5 volts. This 4.5 volts. Without looking at this, I'm just guessing here, is probably a C-style bias. Usually they use good resistors, cathode resistors rather, for the good bias, but this one looks like it might have a fixed good bias, so that's interesting. So we've got 5 volts for the rectifier filament power, and then the B plus power comes off there, goes through, looks like 2 filter chokes, filtered by 3 capacitors, and then a little extra capacitor there. This is probably for the output, maybe? I'm not sure that. I'm not sure what that's for. Anyway, if we look at the speaker output here, right there in that kind of bluey writing, that's the speaker connections, and you can see that these B connections come right off the B+. This would be the B+ line. You can see how the B+ goes in through that transformer to that plate. And then it also goes over to the speaker connection, then it will go through the speaker and then back into the plate here. And that is why I needed to order this. So this tube can either be a 112 or a 171A. And in this case, you got a 171A. Now the high impedance speaker that I have, that I've used in all these other videos about these old radios that need high impedance speakers, that speaker is not rated to handle the plate current of the 171 tube. So what I had to do is I ordered this, which I can open it while holding the bendy pad. What this is an output choke. So I'm going to hook this up the way that an output choke would normally be hooked up for use with my so 100A speaker. So I'm just going to hook the filter choke across these 2 points, not the filter choke, the output choke. This thing just has, just a coil of wire, just has 2 ends, and it's a coil of wire around a iron core. And what that's going to do is that's going to provide impedance, creating a voltage drop between these 2 points, which is needed for, basically it's your plate resistance essentially. So that, because if you just shorted these 2L, then this plate will be connected to B plus all the time, and you never get any voltage variation there due to the large filtering on the B plus. So you need some kind of resistance or impedance there, which allows you to have a voltage drop so that this plate voltage can vary up and down with the signal. So what I intend to do is hook the output choke that I've got across these 2 points, thereby creating a plate resistance, and then I can take my speaker and connect it from this side of the output choke to ground, which is, you also use a capacitor too. So I have a capacitor coming off at this point, going into my speaker, which will then go to ground. And that way the voltage variation here on the plate will cause current variation through the speaker, an AC signal going through the speaker filtered by that capacitor I'm going to put in there. And that will allow my speaker to work with this radio. They did have speakers that were designed to go across here, just I don't happen to have one, so that's why I went with this. This is much more attainable and a lot less expensive. I think this is only like a couple dollars actually for this thing. Actually, I think they had a minimum order of like $15 or something, so I actually had to add another transformer to my order to make the minimum order amount. So this is a lot cheaper and a lot more attainable than finding the correct speaker to use with this radio, and it should work just fine. So before we power this up, I'll have to get that put in. I'll probably also double check, just do a quick resistance check on these capacitors here to make sure that none of them are shorted so we don't blow anything up. And then I think that once I've checked these out and got my capacitor and output choke and speaker hooked up, then I think we'll be ready to test this out and see what happens. Okay guys, I think we are ready for a Powerup test. I just hacked on this cord temporarily so I don't have to worry about the old one with had all those holes in it. I bypassed the power switch because that's bad. Wasn't making continuity in either position, so I just put a jumper across it, so we'll plug it in to turn it on. This wire here goes down, not sure if I can show you here, but basically it goes down underneath, and you see that capacitor right there? So that wire just goes right to that capacitor. So I assume that was someone's attempt to reduce interference. I've just cut that off for now. I don't know the state of that capacitor, so just not worry about that for the time being. Got my probe in here. This should be the B plus side. So I can check the B plus. I've got one wire going from that over to the input side of the output choke, and the output side of the output choke goes to this capacitor and also to this lead, which goes to the other terminal here. So the B plus should be going out through that lead, through this choke, back through this green wire to here, which goes to the plate of the tube. And then I've got this capacitor here for DC isolation with this lead on. And once I power this up, I'll just do a quick double check to make sure that there's no voltage on this side. There shouldn't be, but just, I'd rather be paranoid than risk destroying my 90-year-old speaker. So I'll just double check to make sure that there's no DC voltage here. And then I'll hook this lead up to this. There's the other end of my speaker. And then the other end of the speaker goes into this terminal here, which just so happens to be ground. I think this is a phonograph input. Doesn't look like a very good one because based on the schematic it looks like it just plugs in right across the radio signal, and I guess the idea is that the phono signal is supposed to be so strong that it swamps out the radio signal, but whatever. Anyway, this side is ground, so I've got the other end of the speaker plugged in there. I think we'll just power this up and see what we get. I'll be monitoring the B plus with my meter right there, and just like this off the ground here. and this should be making connection against that clip lead, so hopefully that'll be okay. And we'll see what we get. Everything in the frame here. See that meter. No, 210, 209, so that's dropping. And the drop as the tubes warm up and start conducting. So it doesn't seem like it's been like massively overloaded or anything. Can you see the tubes glowing yet? I do hear something humming though. I see the rectifier tube glowing. See the output tube glowing. Don't really see these tubes glowing though. I have to double check voltage on those. I'll turn off the lights just to be sure. You hear a lot of humming too. The output tube is glowing. I don't see any of the other tubes glowing though. I doubt they're all bad. I'm only getting one. Yeah, so the output tube is glowing. Oh, that one started glowing when I wiggled it. So we got film voltage for the output and for the detector, but I don't see anything on these tubes. So let me turn this off for a minute. And I'll double check which connection here on the output, the terminal board there is supposed to be for the filament for those tubes. So the 26 tubes are this 1.5 volt, and that comes off and goes over to, it looks like these second ones here. So this would be these two right here. And actually that looks like where a crappy solder joint is, so that might be a problem right there. Looks like the one in the bolt, I'll probably just show you that. It's like one of the nuts broke off and someone just tried to solder it back in place. So what we can do is, first of all, we can check area of continuity from there to these filament pins. Just put that there, 2 ohms. So from here, this might not be a great reading because it's going to go, if one side is open, it's still going to go through all the other tube filaments to the other side. So let me actually pull all of these out, just to be sure. These tube sockets don't seem to be the best quality, but some of them are pretty loose and some of them are rather tight on certain pins. Okay, so let's just check. So you have continuity between the two. So that looks good. I'm seeing 4 ohms resistance. That should also be the same taken from right here. 0.8 to 0.7, okay. Unless one of these tubes is shorted internally or something. Try popping some of these back in. could also be that there may be a short in the wire somewhere. So you can double check that too. It's going to be hard to check that because the transformer wire is going to be so low. So what I'll do real quick is I'll power this back up. Actually, we don't be on AC. Sorry, AC filament tubes. And we will check the voltage on that and just see if it makes sense. The voltage is 1.0, so it's a little bit low. Should be 1.5. Let's check what it is here. It's a little bit low, so I wonder if there's like an excessive load on that or something. Doesn't seem like these tubes are lighting up. You can see how brightly that one's lit up and how that one's lit up. You can see a little bit of glowing in there. But you can't see anything at all. Oh, no, do I see anything? No, it's just the reflection of my multimeter. That also has an orange, but just the reflection of my orange multimeter in the glass. You don't see any glow on the filament in there. So, there's something squealing. I think what I'll do is I'll take loose, what I could do is take all these tubes out and check the voltage again, and the voltage should be high then. There's no load on it. This tube feels a little bit warm though. I really don't like these tube sockets. This one doesn't really feel warm. This one doesn't really feel warm either. Alright, so let's try it again. Go on AC volts. Yeah, 1.7. So that's reasonable. I wonder if one of these tubes is bad or something. Let's try plugging one in. Is the right connection here? That tube should be lighting up now. Let's try adding some more here. If we get any glowing on any of them. We can also double check and see if our voltage is dropping. 1.1, that's a little too low. So which tube could that be? Could it be this one? .2. Could it be this one? Now got 1.7, okay? So I'll try popping this one in. Switch to wire there. We've now got 1.1. Oh, that's weird. I wonder if this tube is just open then. It doesn't seem to add any load. I'm gonna have to do some more checking into. That's because that voltage is definitely pretty low. That's, this tube is bad. Should taking this one out. Oh, well that might do it. That's a 45 tube. That doesn't belong in there. Actually, that shouldn't really have made much of a difference. So let's see, what voltage do we have now? 1.0, no, it's still low. Yeah, somebody stuck a 45. I don't think that's right. I'm just going to play around with these for a little bit. You can still see what I'm doing. Yes. So right now I've got one tube in, and the voltage is 1.2. Should be 1.5. Now if I add a second tube, add this one here, voltage goes down to 1.1, so a minimal drop. If I add another one, how's if I orient them right? If I add another one, the voltage goes down to 0.8. Those two feel a little bit warm. This one on the end here. I don't really see any filament glow in it. I don't see any filament glow in any of them. If I pull this one, what does our voltage do? Doesn't look like it has any oxide on it either. At 9.2. Make sure I don't add the 45. That's a 45 that doesn't belong in here. If I add this one. At 1.5, yeah, I just don't think that that's enough to make these tubes glow. Although it's interesting because even if I take some out, let's take this one out. So we have 1.1. Okay, yeah, now I can see some glowing from this one a little bit. Don't see anything from that one though. I know some of these tubes are bad. Let's add this one and see if we get any glowing from this one. These tubes take a while to warm up because they have such heavy filaments. Right down below a volt, so definitely something that's not seeming quite right here. There's a resistance point somewhere. If I measure directly across this again. So I only got 1 volt. What's this point down here? This is just not making a good connection here. Maybe. So at 1.3 on the bottom side of that bolt, only 1.1 on the top, so a little bit different. So let me replace that bolt for one thing. What I was doing was, so this is the top side that goes off into the radio. One side of that, these 2 points here are the 1.5 volt filament supply, and these terminals go off into the radio. And measuring from this, the center of this bolt to here was only about like 1.1 volts. So measuring from this bolt to this connection on the bottom was more like 1.3. So not as high as it should be, but it's still a little bit different. So I'm assuming that whatever is going on here is causing this to not make a good connection. So let me see if I can replace that bolt and get a good connection and see if that improves our voltage at all. Okay, so it turns out these are actually not just regular bolts. So you can look in the side there. See those brass standoffs there? Those are actually part of the same piece. So it looks like they've taken these brass standoffs and then machined down and threaded the end. So it's not like a regular bolt that you can replace. So for now, I've just hooked a clip lead across from here to here. On the bottom of this, and also on the bottom of this, they have a rivet on the bottom of that brass thing. So across the bottom is the balance. I guess you're gonna call it a balancing resistor. Basically, it's two resistances of equal resistance. I think they're usually like 40 ohms or something low, and with ground connected in the middle. And what that does is it makes sure that the two sides of the AC line are balanced around ground. So this brass standoff goes down and then has a rivet on the bottom that rivets this connection coming off the transformer to that resistor going across the bottom, and then has a standoff in between the plates, and then has the bolt on top to attach this thing, this terminal. So now I'll just put this jumper across. We'll see if that increases the voltages. This is not the correct wire for this. This is a high current capacity. We'll just see if this helps. I think each of these tubes draws 1 amp, so we'll have to get a better wire. And it looks like my tripod tightening thing has stripped out, so that's nice. So I can no longer tighten my tripod down so it stays in one place. Okay, anyway. So the tube that they had in the RF, or the input antenna amplifier, was actually a 45 tube. So this is designed for 2.5 volts instead of the 1.5 that this is supposed to be getting. So this probably could have helped drag down the filament. Not exactly sure what the current rating of this is. At its rated voltage, it'll probably be a little bit less current at this voltage, but either way, it's not going to work with that in there. Even if this wasn't dragging it down, it wouldn't get to the right temperature. The filament wouldn't get to the right temperature to conduct properly, so you'd barely get any gain. And second of all, it's an output tube. So the output tubes aren't designed for providing massive amounts of gain anyway. They're designed for driving high power loads. So this is certainly not helping. And I've also confirmed that this tube has an open filament, so this is not going to help us either. So we've only got 3 good 26s in there now. I'll try powering this up again, and we'll see if our filament voltage has improved any. We've got this back on AC. Let's plug this in. And we can check now and see what we are getting. 1.2. So it's a little bit better, although still not great. It may rise a little bit as the tubes heat up, because they'll draw a little bit less current as they heat up. I'll wait on this and check the voltage right across there. 1.3, 1.32 there, and here we've got 1.3 for a second. So this is probably getting 1. No, not really. Could just be a bad connection too, because I just clipped on here. So right across here we've got 1.1. If I go down to here, we've got, let's just go to 4. That can't be right. Doesn't seem correct. Shouldn't be at 4. It's at 0.9. I wonder if my meter is screwed up. See if these two are actually wrong. Barely. Those two in the end. So the output tube is nice and bright. The detector tube is nice and bright. This tube is barely noticeable. It might be okay. This one doesn't seem to be glowing at all. This one barely. I'm not pointing the camera correctly. It seems to be barely glowing. So I wonder if maybe this socket is screwed up or something. My meter reflection is screwing with me too. my orange meter keeps reflecting off the glass making me think the tube is glowing. Maybe that one's glowing. Kind of hard to tell. A little bit, I think. Doesn't feel warm though. This one feels warm. So 1.1. 1.3. So we'll definitely have to come up with a better solution, I think, to get this connected properly. So 1.3 is a bit low. It should be 1.5. I'm gonna have to order some new tubes too. Some of these I'm not sure if I should trust them. And then plus I got the 2 bad ones. So anyway, that's gonna be it for now. I have to order some tubes and dig further into this voltage problem. Okay, so I've been playing around with this thing, and I think I might have narrowed down our voltage issue. So first of all, this was not making a good connection on this side. I've now soldered a, not light duty, it's heavier than the wire that comes from the transformer actually, so this should be fine, because this wire was going to carry a lot of amps. I think each of these tubes, each filament draws 1 amp, so got what, 5 tubes, that'd be 5 amps, so you don't want to skimp out on this wire. Anyway, put that jumper on, since I'm not going to be able to replace that bolt and nut because it's that fancy machined piece. So this will do. Make a good connection there. And also on this side, I took the nut off and cleaned up the bottom of the nut and cleaned up the top surface and put it back on. I was getting some funny voltage readings, like going from the post to the terminal connection there. So I wanted to get that cleaned up. So now I'll show you what I found. I've also hooked our speaker up, even though we're not going to receive anything, because we're still missing those 2 tubes. Get the meter back up on top here. It's in AC volts mode. Let's see that. Plug this guy back in. So we're getting a little bit of hum out of the speaker, but that's normal for a radio like this. Also because we're missing some of the input circuit, so there's some open inputs down here. That's what's not entirely surprising. I'll check the filament voltage now. 1.32, so doing better than we were before. Before we were down to like 1.1. I think these tubes are still warming up somewhat. So it really seems to have improved it. I'm going to try cleaning it up a little bit more yet still. See if I can get an even better connection there. If I go right across these, also 1.3. I'm getting some funny readings here, I think, sometimes. Sometimes I don't always get that reading. Now it says 1.5. So I'm not sure if that's an issue with my meter, or what exactly the deal is. Right here, what do we have? Now we have 1.486. So is there still a funny connection here? That it just take that long for the tubes to warm up? Because as the tubes warm up, the current draw decreases. So as the current draw decreases, the load is going to decrease and the voltage is going to rise naturally. So when you first turn it on, you're going to get your lowest readings. Just found it kind of weird that I didn't see it. Like when I first measured it, it didn't look like it was going up. But now it's up at, now it is up at 1.487, which is pretty much what it's supposed to be, 1.5 volts. We'll have to see how it fares once we put the other 2 tubes in, see what that load does to it. But if it stays there, then I'm going to consider that issue solved. We'll have to see. So, next thing that I wanted to test was, actually we could also test too, is the B plus here. This on DC. So what we can test is the B plus. We'll go right on this, or right on the end of my clip lead, because it's hooked right up to the B plus. There's a ground. Good connection there. Do we have 153? Yeah, that's probably acceptable. 153 is probably just fine for the B plus. You can check the other side here. Going into our output tube. At 142. Yeah, that's probably fine. I'm not sure if the schematic calls out voltages, but definitely fine. We can check our output tube filament voltage as well. That should be 5 volts. And we are seeing 5.72. That's a little bit high. Could be that it'll go down once we add a little bit more load to there. Not quite sure what else would cause it. I verified that is the right tube at 171. So if it's high, we'll just have to be that the radio is a little bit off on its performance. Could also be that this was designed for 110 volts and we're running it on 120. Usually, a lot of these have a different transformer tap for 110 versus 120. So I can check into that as well and see maybe if that needs some adjustment. But if we adjust that, then we'll also be lowering the filament voltage for these tubes, so it might require some further investigation once we have those tubes to do a full test. What else we can do is just check and see how far our signal can make it through. So what I'm going to do is I'm going to poke the grid connection. I'll stand over here so I don't block the speaker. I'll poke the grid connection of each of these tubes and see if we get any noticeable sound out of the speaker. So here I'll poke the grid of the output tube. There's definitely a change there, so the signal is at least getting to the output tube. Now let's try, this is probably the audio amp. There's definitely a signal change there. This will probably be the last RF amp here. There's definitely some change, and we'll go back to this RF amp. Definitely less change, so could be that this tube is weak. It is the only globe 26 left in here. I'm not sure if you're able to see it, but if you look at the filament looks kind of misshapen. I'm not sure if you'll be able to see. Can you kind of see how the filament, so there's like a little kink in it. Looks like it's kind of drooping a little bit. It's kind of hard to see through the camera, but it does look a little bit misshapen, so it could just be that that tube has quite a few hours on it and it might be near the end of its life. So maybe I will place another order for another 26 tube, change this one out, see if we get any difference, because ideally the further back you go, the higher the gain should get, because you're going through more gain stages. So like the gain from here to there, you can, I don't know if the camera will pick it up because of the compression, but I can hear that the second one is a lot louder because it's got this extra stage of gain. But going from here to there is a decrease in gain, so I'm a little suspicious of this tube. Could be something else in the circuit. I would be highly suspicious that it'd be any of these coils. They look to be in excellent shape. I don't see any damage on any of them. Of course, I look all the way at the bottom, but usually if these are going to be bad, they're going to be open, not going to cause a reduce in gain like that. So I might order another tube replacement for this just to see if that will help us any. But other than that, I don't really see anything to worry about here. You can check our voltage one more time just to see what it is now. Just double check here. We're still at 1.47, right around 1.48. So Like I said, I'll have to see how it goes when we get those other two tubes in, but I think I'm going to stop this video here, and we'll save that for part 2. I don't know what else this video is going to need to work, so I'll make this at least a 2-part video, and we'll stop part 1 here and pick up part 2 when we have the tubes back in. So hope you enjoyed this video, and thank you for watching.